All right, so I'm doing my second derivative test. I have my second derivative. I have my critical numbers from the second derivative. They were here. And now I'm going to set up my table. And I set up my table just to keep everything organized. Since I only have two critical numbers, I'm only going to do two dividers. And my lowest is -2. My highest is 2. The end of my table would be -infinity and infinity. I get to pick my own x values to test. And I'm looking to see what the second derivative value is, because if it's positive, it's concave up. If it's negative, it's concave down. So what number do you like between -infinity and -2? I'm going to pick -3. What number do we like between -2 and 2? I like 0. What number do we like between 2 and infinity? I'm going to pick 3. Now I have to go back and plug it into my second derivative. I have my best second derivative, I feel like, is my simplified derivative. So I'm going to go back and plug it into here, and I'll do my best to figure that out. So it looks like the top would be -10 times -3 squared would be 9. 9 times -3 would be -27, and -4. The bottom would be -3 squared. 9 minus 4 would be 5 cubed. So it looks like on the top I end up with -10 times -31. Negative times negative is positive, so I end up with a positive number on top, and that's 125. Positive number divided by a positive number is a positive number. So here I end up with a positive number, or second derivative greater than 0. Greater than 0. So if it's positive, that's an automatic concave up. Concave up between -infinity and -2. Do the same thing with 0. So I'm going to plug it into my second derivative. Okay, I'm going to plug it in here and here. So I end up with -10, and then that would all be 0, so times -4. And then 0 minus 4 on the bottom would be -4 cubed. Well, -10 times -4 would be 40 on top, and that would be -64 on the bottom. So positive divided by a negative, negative. And a negative means my second derivative is less than 0, which means it's concave down. Now I'm going to check 3. I'll plug in 3. And because I'm plugging it into an x squared term and an x squared term only, my 3 result has to be the same as my -3 result, because -3 squared is 9 and 3 squared is 9. So I'm anticipating the same result. That means it will be positive. And that means it is greater than 0. It is concave up. So to summarize my results, I'm going to write a little blurb here and write concave up from, and again I use these are not special at all, I chose those. These are special because I found those are critical numbers. So concave up from -infinity to -2, and up was 2 to infinity. Concave down was -2 to 2. It also asked me to find the inflection points, and inflection points happen when you have a change in concavity. So here we went from up to down. That's a change in concavity. So -2 is a possible inflection point. Here we went from down to up, change in concavity. That's a possible inflection point. The reason that I say inflection point, or possible inflection point, inflection points at, is because this one is a fraction. I know I have some issues with numbers being defined. And if you look all the way back up at your original function, if I were to plug in 2 and -2, I would get divided by 0. So, you know, they happen to be where concavity is changing, but when I go to find my y value, it's undefined. So they end up to be duds. They're not actually inflection points. I would would say inflection points at nowhere. Because the two that I had as my possible inflection points ended up being, they weren't inflection points because they were undefined at the y value. What are they? Well, these end up being vertical asymptotes because it's when the bottom equals 0. So that's why they popped up as critical numbers, but ended up not being inflection points.